Hello everyone and welcome to Learnaholic India. So today we are going to see what is machine learning. Machine learning is a scientific study of algorithms and statistical model that computer system use to perform a specific task without using explicit instructions, relying on patterns and inference instead. So today's agenda is what is machine learning, history, that is evolution of machine learning, what are the types of machine learning, supervised learning, unsupervised learning and reinforcement learning. So let's start with the definition of machine learning. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of a computer program that can access the data and use it to learn for themselves. The process of learning begins with the observation or the data, such as examples, direct experience, or instructions, in order to look for patterns in data and to make better decisions in the future based on the examples that we provide. The primary aim is to allow the computer to learn automatically without human intervention or assistance and adjust the actions accordingly. Now let's see the brief history about machine learning. Machine learning is an important aspect of modern business and research. It uses algorithms and neural network models to assist the computer system in progressively improving their performance. Machine learning algorithms automatically build a mathematical model using the sample data. It is also known as training data to make the decisions without being specifically programmed to make those decisions. Machine learning is in part based on the model of brain cell interaction. This model was created in 1949 by Donald Hebb in a book titled The Organization of Behavior. The book represents Hebb's theories on neuron excitement and communication between the neurons. In 1950s, Arthur Samuel of IBM developed a computer program for playing checkers. Since the program had a very small amount of computer memory available, Samuel initiated what is called as alpha-beta pruning. His design included a scoring functions using the positions of the pieces on the board. In 1957, Frank at the Cornell Laboratory combined Donald Hebb's model of brain cell interaction with Arthur Samuel's machine learning efforts and created the perceptrons. The perceptrons was initially planned as a machine, not a program. The software originally designed for the IBM was installed in a custom-built machine called as Mark I Perceptron, which had been constructed for image recognition. This made the software and the algorithms transferable and available for other machines also. In 1967, the nearest neighbor algorithm was convinced, which was the beginning of the basic pattern recognition. The algorithm was used for mapping routes and was one of the earliest algorithms which is used in the finding a solution to the traveling salesperson problem of finding the most efficient route. Using this algorithm, a salesperson enters a selected city and repeatedly has a program visit the nearest cities until all have been visited. In 1960s, the discovery and the use of multilayers opened a new path in a neural network research. In late 1970s and early 1980s, artificial intelligence research has focused on using logical, knowledge-based approaches rather than the algorithms. Additionally, neural network research was abandoned by the computer science and artificial intelligence researchers. This caused a screams between artificial intelligence and machine learning. Until then, the machine learning had been used as a training program for artificial intelligence. Boosting was necessary development for the evaluation of the machine learning. Boosting algorithms are used to reduce bias during the supervised learning and include machine learning algorithms that transform weak learners into a strong ones. Currently, much of the speech recognition training is being done by the deep learning technique called as long short term memory, a neural network model described by SAPE in 1997. Long short term memory, that is LSTM, can learn tasks that require memory of events that took place thousands of discrete steps earlier, which is quite important for speech. In 2006, the Face Recognition Grand Challenge, a National Institute of Standard and Technology program, evaluated the popular face recognition algorithm of the time. 3D face scan, iris image, and high resolution face image was tested. Recently, machine learning was defined by the Stanford University as the science of getting computers to act without being explicitly programmed. Machine learning is now responsible for some of the most significant advancements in the technology, such as the new industry of self-driving vehicles. Machine learning has prompted a new array of concepts and technologies, including supervised and unsupervised learning, new algorithms for robots, the Internet of Things, analytics tools, chatbots, and many more. Some of the examples which are using by the machine learning are analyzing sales data, real-time mobile personalization, fraud detection, product recommendation, learning management system, dynamic pricing, and natural language processing. Now let's see how does machine learning work. Machine learning algorithm is trained using a training data set to create a model. When a new input data is introduced to the machine learning algorithm, it makes a prediction on the basis of the model. This prediction is evaluated for the accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. If the accuracy is not acceptable, the machine learning algorithm is trained and trained again with an augmented training data set. Now let's see the classification of machine learning. There are three types: supervised learning, unsupervised learning, and reinforcement learning. Now we will see it one by one. First we will see what is supervised learning. Supervised learning, you feed the output of your algorithm into the system. This means that in supervised learning, the machine already knows the output of the algorithm before it starts working on it or learning it. A basic example of this concept would be a student learning a course from an instructor. The student knows what he or she is learning from the course. With the output of the algorithm known, all the systems needs to do is to work out the steps or the process needed to reach from the input to the output. The algorithm is being taught through a training dataset that guides the machine. If the process goes haywire and the algorithm comes with a result completely different than what should be expected, then the training data does the part to guide the algorithm back towards the right path. Now let's see what is unsupervised learning. During the process of unsupervised learning, the system does not have concrete data set, and the outcome to the most of the problems are unknown. In simple terminology, the artificial intelligence system and the machine learning objective is blinded when it goes into the operation. The system has its flawless and immense logical operation to guide it along the way, but the lack of proper input and output algorithm makes the process even more challenging. Incredible as the whole process may sound, unsupervised learning has the ability to interpret and find out the solution to a limitless amount of data through the input data and the binary logic mechanism present in all the computer system. The system has no reference data at all. The third technique is reinforcement learning. Reinforcement learning is another part of machine learning that is gaining a lot of prestige in how to help the machine learn from its progress. Reinforcement learning is not simple and it is tackled by a different algorithm. As a matter of fact, in reinforcement learning, an agent decides the best action based on the current state of the result. The growth of the reinforcement learning has led to the production of a wide variety of algorithms that helps machines to learn the output of what they are doing. Since we have the basic understanding of reinforcement learning by now, we can get a better knowledge by forming a comparative analysis between the reinforcement learning and the concept of supervised and unsupervised learning. In the next tutorial, we are going to see the comparison between the reinforcement learning and the supervised learning as well as the unsupervised learning. Now let's see the basics algorithms for supervised learning. There are various algorithms used such as logistic regression, support vector machine, decision tree algorithm, k nearest neighbor, naive Bayes, linear regression and polynomial regression. There are various unsupervised learning algorithms also. Some of them are clustering, hierarchical clustering, k-means, anomaly detection, autoencoders, neural networks and expectation maximization algorithms. Let's see the major applications of reinforcement learning. Traffic light control. Researcher tries to design a traffic light controller to solve the congestion problems with the help of reinforcement learning. In robotics, there are tremendous work on applying reinforcement learning with the help of various algorithms. The next application is web system configuration. There are more than 100 configurable parameters in a web system, and the process of tuning the parameters requires a skilled operator. Reinforcement learning is also used in personalized recommendation, a deep reinforcement learning frameworks for news recommendation. Remember one thing, sharing of knowledge is gaining of knowledge. That's it for today. Thank you for watching today's session. If you are new to this channel, then subscribe to Learnaholic India and don't forget to click on the bell icon for the latest video updates. If you like today's video, then like it, share it with your friends. Also, if you have any query, then please comment below. That's it for today and stay tuned for next video. Thank you once again.